So today our main theme is about to design EVs, electric vehicles and plug-in hybrid electric vehicles charger, fast vehicle charger through MATLAB Simulink. First of all, coming towards the web browser, selecting Power GUI. Then after Power GUI, coming towards voltage, source, in Simulink library we are moving towards the voltage source, AC voltage source. So we will select this one. Make it Control R, right side. Control C, and then Control V for copying and paste. 3. We are going to paste total 2 and total number 3. So number of AC voltage signals are 3. It means that we are going towards 3-phase system. Now the peak amplitude voltage is going to be 230.9 volt. The frequency is going to be 50 hertz, but if you are living in some other countries like European, so it may be 60 hertz, depend upon the scenario. Second phase is also having 230.9 volt peak amplitude voltage. Phase degree in this one it was 0, so now here it will be 120 degree apart from the first one. Frequency is 50 hertz. Okay. Again 230.9. Now here phase degree will be 240 degree phase shift. Actually 0, 120 and 240. It means that all the three phases are 120 degree phase difference between each other. Frequency remains same, peak amplitude voltage remains same, only the phase degrees. It also between every two phases 120, but in 360 degree you are going to manipulate it according to the scenario. Now VI measurement. It is for voltage and current measurement. The system which we are just using is 12 pulse uncontrolled rectifier or 12 pulse diode uncontrolled rectifier. So for that we are having 3-phase 3-winding transformer. don't know why it's not coming. Okay, now it's come. 3-phase 3-winding transformer. Now it's actually in 3-phase 3-winding transformer. In the primary side we are having 3-phase, and at the secondary side we are having 6-phase. Remember that at the primary it is 120-degree phase shift between every 3 phases, but at the secondary side it is having 6 phases, so the phase difference will be different. 60 degree, it will become 60 degree. Now coming towards bridge, universal bridge, we will select universal bridge because universal bridge contain 6 diode or transistor, but we will select universal bridge for diode. Uncontrolled rectifier, select from here, apply. Now you will get okay. Actually we need 2 universal. I will just show the universal bridge diode internal infrastructure so that you may know the information about the internal. So this is the diode bridge, universal bridge rectifier. You can see 6 diodes are being placed, Q1 up to Q6. Control C and then Control V, paste another one. Make it a little bit larger. But the thing is that we need another 2 VI measurement. We just want to identify the output voltage from 3-winding transformer towards the 12 diode rectifier or 12 pulse with 0 pulse uncontrolled rectifier. Now connect just like this. Now coming towards the library browser, select RLC branch, series branch, Control R will be flipped. We just select capacitor, make it 10 microfarad. Okay. series, we are going to select resistance 10 ohm, play. Coming towards the 3-winding transformer, so at the primary side it will be delta connection. Winding 2, it means that at the secondary one is going to be star and the other is going to be delta. Apply. And now we're coming towards the parameter, so here we are going to have 8000 nominal power watt. Sorry, VA. Frequency is going to be 50 Hertz, and V1 RMS we are having about 400 watt because the peak voltage was 230.9, so the peak to peak VRMS will be 400, about 400, and here V2 peak to peak should also be 400, but you can just change if you want, step up or step down. Okay, everything okay in per unit. Apply and okay. Now coming toward library browser, ground, type ground, this is the ground, select this one, now it's better. Now a battery for EVs, according to the EVs, just like Tesla cars are using lithium ion battery, so we will also use lithium ion battery. Flip towards right, now it's correct. Okay, now actually now removing capacitor just to test it. Coming towards bus bar or bus. For the battery, the diode, depth of discharge and all stuff. Double click on it. The bus selector. Okay, so state of charge, current ampere. Select. It will come on the signal side, so that's why I'm just selecting it. And remove these two signals. Apply. Now it's got better. Coming towards the scope, test another one. Coming the current. Now coming towards another scope, 3 scopes. Oh, lot of. Why not just move it here? So much easier. Yeah. Much better. You can see it is state of charge in percentage, current, voltage. Now going on the next thing, double click on the scope data scope. We are going to change some setting internally in that, just because for the FFT analysis we have to identify the total harmonic distortion of input current and peak to peak ripple voltage and current at the output side. So for that I am going to change some internal infrastructure in that. Going to the setting, coming towards the logging data workshop, it will become 1. And yeah, okay. It will become 2. Okay. Logging data to workshop, it will become 3. That sheet is much better. Okay. Coming towards the logging, it will become 4. Data scope data 4. It will become scope data 5. Logging workshop, and now it will become 5. So remember this to change the internal setting of the scope. Coming towards the logging, it will become 6. Scope data 6. Okay. This one scope data 8. Sorry, scope data 7. Okay. Now here scope data 9. Okay. Double click on scope data 8. Coming towards the setting, logging data to workshop, and now scope data 8. I'm just wanna view it. Okay, that's right. Okay, now the next thing is that we are going to run it, but first of all, just changing the color. Right click, AC voltage source. It is just taking some little bit time. Okay, now coming towards the format, background color, it should be red. Okay, format, it should be green. It should be yellow. Transformer, T1 transformer, I think so. Gray will be, no, yeah, gray will be okay. Diode, green. Oh sorry, that's green. It should be green. And it should be yellow. It's easily to then identify, so that's why I just using it. We just running it at how it sends its output and input. It's been compiling. After compiling, it will be start its timing from 0 second to 10 second. We have selected 10 automatically. Compiling is just because to identify any error. If it is having, so it will identify to us. If no, so then it will proceed towards the further step. Okay, so now it's, I think so, not having error. So time is being started. That's cool. First checking the voltage. It is 9. I think so. There may be some error. Oh yeah, we haven't changed the battery setting. So the nominal voltage is going to be 900. In Tesla car we have just used an 800 AH. And it is lithium ion battery. Yeah, it's perfect. Okay, apply and okay. Now run. Compiling. After compiling, we are going to check the state of charge, which is 100%. Yeah, that's really good. The current is also much better, 105 ampere. The peak to peak ripples, you can just view it from here, it's much better. The voltage, now it's about 1000. and 50 volt. As we have just changed the battery settings, so everything is been perfect. Now coming towards for peak to peak ripples, we are going to have some coding. Coming towards here, clear all. Everything will be clear. Now just waiting for it. I think so it's just taking time. This is actually the previous, I have done some simulation. I really don't know why it's not. Again coming towards the project, and again the system is much more heavier, so that's why it is just taking time. Actually this whole process is because to identify the THD, so that's why we will find it is taking time. Yeah, MATLAB 2020 the system being hang for a little bit. The THD is for verification of harmonic. Actually, we are going to identify the input current THD, input current total harmonic distortion. This is because that we are going to view that how much harmonic are towards the input current. So rather than if the THD is more, so then we are going to use some highly advanced filter, because this THD is not better for the EV charger, fast EV charger. You can also say fast DC EV charger because we have just changed the AC system to a DC. So that's why now in this case we haven't used DC to DC converter. So in my next video you will view DC to DC converter. If if you guys want, so I can make a video for that. Too many input arguments, so now we are going to have the system. Okay, now that's great. It's been continuing. Checking the voltage, output current voltage, output voltage. Okay, that's good. Now for FFT analysis we are going to have some coding. So now coming towards this coding. Okay, when I just type this, you can say the scope data, which in the Simulink model I was just giving a name to it and changing the setting. Now if I just press enter, so it will look at this A having just came here. Now B will also come there. You can just view it. Similarly C. Now here we are going to have the coding. Stepwise you are going to add the code. lastly 9. So all of which we have just typed it is being come here. It is for now coming towards our model. Now coming towards the Power GUI tools, FFT analysis. Now here you can just view it. In FFT it is the B is actually the current, so frequency is going to be 50 Hertz, starting from this, and any time is 600. Number of cycles. Actually 500. Yeah. Now FFT window, and now display. THD will be displayed now. So the THD is for the input current is 0.1%. It means it is too much low, and the system is much better. Similarly, this is the current, state of charge. This is the voltage, and this is the current. Now here you can just see that it is not a straight line, but if you change the setting, then you will get that it is actually straight line. Coming toward the display, minimum should be 0, and the maximum should be this much. Now I play. Now you can just view it here. Look at this. It is a straight line from 0 to 10 seconds. The peak to peak amplitude I have just increased, so that's why now you can just view it here. Actually it was very much less, so that's why. You can also justify it. Can be seen here. So coming towards the FF2, actually I want to just show you the peak to peak. Okay, so coming towards 6, number of cycle 5, FFT. Okay, so it's a straight line, and now the voltage. Okay, FFT, it's a straight line. So that's it. It means that the (0.86) from 6, it means that 5 number of cycles, it is much more. But as a whole, if you select from 0 to 500 cycles, now display, you will get 0.1. It means the system is much efficient. It is 12 pulse uncontrolled rectifier, 12 pulse with 0 degree phase. In diode, it's mainly if you are considering transistor, so 12 pulse control with 0 degree triggering. Okay, if you want much more simulation videos, so please subscribe my channel and press the bell icon for more upcoming videos. And please do comment in comment section. Please have a comment if you have any queries or any problem regarding the simulation. Thank you so much.